Hello, everyone. Welcome to the last week of the ICP Chain Fusion Educate Bitcoin edition. Today, we are joined by Jennifer Tran from ICP on how to connect 30 plus chains using Chain Fusion. But before we start, just a small reminder to everyone that our hackathon for ICP Chain Fusion Hackathon Bitcoin edition is going to start right after this educate series, so you're highly encouraged to check it out and sign up as well. There will be many bounties involved, and ask me any questions if you have any questions about that. I'm going to invite Jennifer onto the stage to participate as well.
Hello. Hi, guys. Hi, Emma. How are you? Good. I think I'm having issues hearing you. 1 second.
Can you hear me now?
Yeah, I can hear you perfectly now. Great.
Great. Well, I'll leave the stage to you, and I'll be in the background if you have any questions as well.
Cool. Thank you. Thank you, everyone, for attending this session. So we're going to kind of give a high overview of practically everything that we've talked about in this series thus far. We still have one more session after me. So I guess maybe I should have been the last one, but give me 1 second here. And I will share my screen. Let me just go back real quick. These guys got a preview. But thank you again, everyone, for attending. I'm Jennifer Tran. I am a dev relations engineer at DFINITY. So you might have heard from my colleague Moritz earlier in the series. DFINITY is a major contributor to the Internet Computer blockchain. And we have about like over 200 plus employees that are working on the protocol, both on engineering and on the marketing and business sides. And with that, we'll really talk to you guys about how powerful like ICP is with all the research that we're doing. But specifically, we want to talk about Chain Fusion, the feature that all these companies that you've been hearing from in this series, are using in order to build their Bitcoin applications. And I'll talk a little bit more about, what you can actually do. You've already heard about stuff from some of the companies, but we'll just maybe dive in a little bit more on the use cases, go in a little bit more on how it actually works, and just again, give a high overview on what Chain Fusion is. So Chain Fusion, from a high level, it really allows ICP canister smart contracts. They can communicate and connect to other chains, such as Bitcoin, Ethereum, Solana, Cardano. And what that actually entails is ICP canister smart contracts can directly generate an address on these chains and then sign the transaction using that address without like a single point of trust. And that really sets ICP well, as ICP is ultimately a layer 0 for those who are more familiar with blockchain. ICP is a layer 0 or entryway to all of these chains, like where you can interact with all of these chains. For those who want a different explanation, ICP is also a one-stop shop infrastructure for cross-chain. So in the past, you would have, if you wanted to interact with all of these chains, you probably would have a wallet, a smart contract on every single one of these chains, and it probably would be a lot to manage. But in this case, you can use an ICP canister smart contract to kind of be your one-stop shop, one-stop infrastructure for interacting with all these different chains. You don't need to necessarily have, you don't like necessarily have like a billion wallets on different chains. You might not even need to have like all these, smart contracts you need to manage, ICP can kind of be your one infrastructure. And really our vision at ICP is we want to unify Web3. We really think that you can use ICP as this layer 1 blockchain if you want to, but you can also use ICP again as this infrastructure that can kind of connect you to many different chains. And we really think that in the future, developers won't be building on just one chain, but they're really going to be looking to utilize the user bases of many different chains to build their applications, which is really where the industry lies. But as you might have heard throughout the Educate series thus far, is ICP is just much more than just being a unifier for Web3 and Chain Fusion. The whole is actually greater than the sum of its parts. With all of ICP's other functionality, you can actually do a lot more things and really be able to build this on-chain application that is not also cross-chain, but has a lot of decentralized capabilities, has a lot of many other capabilities that are just more than just blockchain. So in this case, ICP also provides like a Web2 like user experience. So for example, we have something called Internet Identity, which is an authentication service for dApps. You can actually sign into an ICP dApp using like a passkey, such as a Face ID or a fingerprint, making it super easy for users to onboard. We also have a reverse gas model, which means that apps are actually paying for the gas on chains, and your users will never have to deal with gas, which is a really good onboarding point for applications. We also have a really big governance ecosystem. So ICP itself is decentralized because it's it is governed by the community. The community decides when an update is made through something called the NNS. Also, DAOs can launch as an SNS. It's a framework that ICP has for DAOs, where DAOs actually give away their code bases to their community. And when they are making updates to their code bases, they actually turn them into proposals themselves. And like each DAO also has a governance token tied to it as part of the SNS framework. Also, like ICP has great computational power capabilities. So you actually can do a lot of computation on chain using ICP. And with that, we also provide affordable on-chain storage. So in conjunction with the computational power, one of our capabilities is the storage. We provide 400 gigs of stable memory and then 4 gigs of heap memory, and we're always trying to hopefully increase that. You can see our roadmap and kind of seeing where we are, always giving teams more performance as well as more storage capabilities. I think the statistic that we have, and when we did run this, is you can actually store 1 gig of data for a year for $5 on ICP. We actually just recently launched this ICP price calculator that actually show if you kind of input how much how many days you want to run ICP canister, kind of what you kind of want to use in terms of the storage. It actually will tell you the pricing. I definitely recommend everyone to take a look at that and see maybe how affordable it is for you to run an ICP as opposed to other applications. We also have this feature called HTTPS outcalls, which allows you to call an API directly in ICP Canister smart contract. And how that actually works is, let's just say hey, you want to say, hey, I want to get information from this weather API. What an ICP Canister smart contract do is call that API, and the nodes will take the API. A couple of nodes would take that API, call it at around the same time. And if the response is the same across all of the nodes, then it will say like, okay, there's a valid response because it's the same. And then it will send it back to the ICP canister smart contract. So you can really do a lot more than just Chain Fusion. I know that that was like a big part of this Educate series, but I want this conversation to kind of help teams think a little bit more on how you can really combine Chain Fusion with really other components, kind of really make a dynamic cross-chain application. And hopefully that will help you guys for the upcoming hackathon or future hackathons that we have as well. So let's dive a little bit more on some of the concepts of Chain Fusion in detail and some of the use cases in detail. So for example, like when I talk about Chain Fusion, we've incorporated a couple of signature schemes in order to enable you to create these addresses and sign for them. So for example, there's a signature scheme called ECDSA. It is a very common signature scheme on many different blockchains, including Ethereum. And by supporting ECDSA and incorporating this technology called threshold ECDSA, that's what actually enables us to allow you to create an Ethereum address and then be able to sign for it. And why we incorporate this? Because again, we want you guys to be able to create these trustless cross-chain applications that use the ECDSA signature scheme, which again is one of the most popular signature schemes on different blockchains. And how it actually works is the private ECDSA key. So of course you have like a public key and a private key. So when you, let's say like you say you want to create a ECDSA public-private key pair, what happens is the nodes create the private key, but it's not shared across. It's not like one node has that one private key and then could steal your funds. Multiple nodes will have different components of that private key and have to then come together. Like let's say like when you want to create like want to sign, for example, they would have to then come together to reconstruct that private key. So we rest assured that there's a huge like security element where not one node will have access to that one private key and potentially like steal your funds or anything like that. And also we have incorporated threshold Schnorr as well. So threshold Schnorr is like the signature scheme, for example, like for taproot addresses on Bitcoin, also like Polkadot, Solana, Cardano also uses ED25519, which is part of Schnorr for addresses and signing. So with threshold, so with threshold Schnorr, this really allows you guys to build cross-chain applications for chains that use like the Schnorr signature scheme. And also the way that it constructs the private keys are also very similar to ECDSA as well. So ECDSA and Schnorr are the two signature schemes that we incorporate as far. We do want to incorporate ECDSA as well for those chains. And then we want to incorporate as many signature schemes as possible in the future. And how here is kind of, I know that for the Educate series, we don't dive too much into code. This is more to help you guys kind of understand the concept, but I think it's still like helpful for you guys to understand like how you might be able to, for example, get like a ECDSA public key and sign for it in a canister smart contract, at least high level, so you know how it works. So we have exposed a couple of functions that you would be able to call to then create an ECDSA public key, and then you can construct a signature. So for example, here, this is just a sign function where you can call like the sign with ECDSA function and then construct your signature. So as you can see here, it's actually a very simple piece of code. For creating a public key is also just a couple of lines of code as well. Towards the end, I can show, or towards the end, I'll show the documentation where to find that. But it just really requires you to call that function, and then you'll get like a ECDSA public key. Also, same with Schnorr. It's also instead of a sign with ECDSA, there's a sign with like Schnorr signature function that you can call to sign a Schnorr signature. And what's great about both of like this implementation is you can have practically an unlimited amount of public keys within ICP Canister smart contracts. So we allow you to actually generate as many as you would need. So what's great for that is like some of the use cases that we've seen is, for example, like one team has created this one ICP Canister smart contract, and then they can actually let's just say like they have like multiple users that they want to create like wallets for or public keys for. They can just as like they have like a new user, they can just create like a new public key for them, and they just have to update something called this deferration path, which is what distinguishes like one public key from another public key in an ICP Canister smart contract. So I've seen instances where teams are saying, hey, I want to create this public key, this ECDSA public key with deferration path user 1, and then the next one is like deferration path as user 2. So yeah, like I think like a lot. So like you can not only just have like one ECDSA or Schnorr public key in a smart contract, we can have like multiple. That can then open doors for you to scale up to many different use cases, which I'll talk about later in the presentation. So let's talk a little bit more on how this Bitcoin integration actually works. So we have something called and Morris had kind of talked about like different subnets and how they work. So on ICP, there is something called a Bitcoin subnet or a Bitcoin shard, where if you want to interact with Bitcoin, this is kind of think about like it's the blockchain within the blockchain that you'll need to query. So ICP itself is a protocol, but we have these individual subnets that you can host your application on. So in this regard, let's say like you want to interact with Bitcoin, you would then be part of this Bitcoin subnet, or you would interact with this Bitcoin subnet. And then practically within this Bitcoin subnet, there is this Bitcoin canister smart contract that teams can actually interact with. So in this case, for example, this smart contract uses like HTTPS outcalls to then fetch blocks from the Bitcoin network, and practically all of the other smart contracts can query the smart contract to get the information. So when I think about it, when you're combining a ICP Canister smart contract with HTTPS outcalls and this ability, to call an API, also this ability to call an RPC, I'm thinking about it like this: an ICP Canister smart contract itself can be this node to Bitcoin, and so like that's again that's the power of it. You can do so much with an ICP Canister smart contract. And what this really opens the door to is, for example, we do offer trustless Bitcoin data. So there is something called a management canister on ICP that allows you to get all this data. So a management canister, think about it as like a protocol canister that anyone kind of query to get some sort of data, or kind of like get some like protocol level data or feature. And so ICP developers can query the following data from the management canister. So in this case, we offer Bitcoin get UTXOs, which returns the unspent transaction outputs of a Bitcoin address. We have this function called Bitcoin get_balance, which returns the balance of a Bitcoin address. We also have Bitcoin_get_current_fee_percentiles, which returns the percentiles of the fees for the last about 10,000 transactions and returns the fee in millisatoshi per virtual byte. And we recently added Bitcoin_get_block_headers, which returns like a requested block header. So you can actually do a lot of interesting things with having this trustless Bitcoin data. Well, first, what I've seen a lot of teams do is they take some sort of this data and do something programmatically with it. Like let's say, for example, today they'll call what your balance of Bitcoin is, and let's just say like if your balance of Bitcoin is over over I don't know, 200 millisatoshis, maybe you get an NFT or something like that. So like that could be, because you would need something that you can verify in order to do something like that. So, and like you can actually do that directly in ICP Canister Smart Contract, or it can maybe set up a timer or some sort of periodic check every day and say, hey, like I want to call this Bitcoin_get_balance and with a couple of Bitcoin addresses. And let's say like, hey, like I just want to know how much Bitcoin this person has. And let's say like, if they're above that threshold, then you can have an automation where you send them like an NFT on ICP or even on another chain as well. So with that, with all of this functionality, there's a couple of use cases that has actually been built out using this functionality. So one of them, I think that'd be really helpful for you guys as you're guys building out the hackathon or learning more about the Bitcoin capabilities on ICP is something we call the ChainKey tokens. So we have a couple of ChainKey tokens already on ICP, and what they are these are digital twins of their native tokens on ICP. So when I say ChainKey BTC, that is a digital twin of Bitcoin. ChainKey ETH, that's a digital twin of ETH. And then ChainKey ERC20s, we have a couple of them, such as USDC, USDT, Pepe. These are the digital twins of the respective tokens on ICP. And if you want to kind of have like a kind of more higher level on what that actually means, it is kind of like almost a wrapped version of these tokens on ICP, but they're actually more secure than like traditional wrapped versions because they're actually programmatic. So how it would work, let's just say like, let's just break it down for ChainKey BTC. So let's just say like, hey, like you want to have ChainKey BTC. How it would work is you would need to take your BTC, deposit your BTC into an ICP canister. In this case, it's a ChainKey BTC minter. You can so remember, an ICP canister smart contract can have like an Bitcoin address. So this ChainKey BTC minter, has a Bitcoin address that you can actually send your Bitcoin to. And then what would happen is it would say, hey, Alice sent 1 Bitcoin to this minter. And then, okay, like now, like, because Alice sent 1 Bitcoin to this ICP canister smart contract called the ChainKey BTC minter, okay, we need to send her 1 ChainKey BTC. And that's exactly what happens. So you send 1 BTC to this ChainKey BTC minter with your ICP principal, or think of it like a wallet address, and it will then send you 1 ChainKey BTC back into that ICP wallet address that you had specified. And so it mints that equivalent digital twin. And then now you can use this ChainKey BTC, and there's other components, like once that ChainKey BTC is minted, like for example, it is like there's like a ChainKey BTC ledger that kind of keeps track of the transactions and the balances. That's like another architecture piece that you have to know in terms of fungible tokens is there's always a ledger for any fungible token on ICP. It's under the ICRC1/ICRC2 token standard. And then you can actually use this token to then transact it on an ICP and use the ICP's benefits of fast finality and low gas fees to interact with this token. There's actually a couple of really interesting use cases that I can actually talk about now that you might use with ChainKey BTC or any of these other ChainKey tokens. For example, let's just say that you want to create a rewards application where you want to reward users with BTC. But it's really expensive, like whether it's like a shopping app or a gaming app, but it's really very expensive for you to just send them BTC every single time they have won a reward. So maybe you want to send them ChainKey BTC first, and then if they meet a threshold, then they can redeem it for actual BTC. So that's one. That's like one use case. I think that's really interesting, where you can you can limit your transaction fees as an application by then like once they reach a certain threshold, then they can redeem it. And then you've seen that a lot with like a lot of shopping apps where you need to like hit a certain threshold before you can redeem like your cash rewards. Another use case that I've seen that I think could be interesting is maybe ICP can be this token swap layer for kind of all the chains. So for example, swapping from BTC to ETH, there's a lot of complex layers there. And also like the gas fees are pretty high, but instead, let's just say like you want someone to swap from BTC to ETH. Maybe you can, in the background, kind of have it be ChainKey BTC and then swap into ChainKey ETH. It's kind of still on this one chain, and then at the end you can help them redeem to ETH. There's a couple of other with like the ECDSA calls and this ability. We also like provide teams with other infrastructure as well. So for example, we have in this EVM RPC canister, and we're hoping to have it we're hoping to have it for Solana as well, but it's actually very similar to kind of think of it conceptually, very similar to how you can think of it like a management canister, but it is slightly different. So think of it as this like decentralized like RPC. So an ICP canister smart contract, again, can call like an API, right? So this uses ECDSA calls to make API requests to RPCs. The kind of common ones are Cloudflare, Alchemy, Anchor, or BlockFi. And it then like calls these RPCs, like the nodes, multiple nodes will call these RPCs and make sure that all of them have like the responses are the same. If the responses are the same, then it will return a response, kind of making it like almost like decentralized like RPC. And these API keys are managed by DFINITY, but you can also use your personal keys. So we also offer this on EVM, like I mentioned, but you can in the future we'll also have one for Solana. So in terms of some of the use cases, we've also heard of these projects already during the Educate series and also like the last Educate series as well that are using Chain Fusion. We've heard from Bionic, which builds a decentralized ordinals marketplace. So what's really interesting about them is not only are they using ICP to actually deploy their full stack application, they also allow users to buy ordinals using ChainKey BTC, and they also have their kind of built-in like wallet. Where like built-in wallet as well, where I believe they are using ICP Canister Smart Contract to create these Taproot addresses that you can interact with. We also have, you've also heard from Omni. They are a interoperability protocol. They are kind of omni-chain protocol that utilizes Chain Fusion to be able to kind of make all those cross-chain transactions. We also have local mining, which is, think of it like a decentralized mining pool for Bitcoin, and you hear from them during the hackathon. Aureli, they are an on-chain oracle. They use HTTPS outcalls to kind of create this oracle service. There's other a lot of our dexes already are building these ChainKey BTCs as ChainKey ETH, as well as ChainKey ERC20 like swap pools or swaps where you can make these swaps already, and technically you can save a lot in gas fees with that. I mean, the caveat there is, of course, like your users will have to have like ChainKey BTC or ChainKey ETH or ChainKey ERC20s. But let's imagine like everyone did have them. It would probably be much cheaper to, let's just say like you swapping ChainKey BTC and then to ChainKey ETH, as opposed to let's do actually doing a BTC to ETH swap. That would probably take a lot more time, and then of course a lot more money as well. So you can do that swapping on ICP, and then redeem whatever end token that you want to have. Like I think what would be really crazy is, let's just say like you want to do some crazy swap between ChainKey BTC to ChainKey ETH to ChainKey USDC, USDT, ChainKey Pepe, some crazy multi-swap there. ICP would actually be a really good use case for that. DFINITY, they actually are an EVM that, there are an EVM that actually is built on top of ICP. So a couple of other use cases that I think that are really impactful for teams, where as you're kind of thinking about like what to build and why this technology matters is, for example, maybe think about like multi-chain governance. One of the biggest pain points is, let's say like you have governance on one chain and then maybe on another chain, or if you're an application that is on multiple chains, well, how are you going to deal with, if you ever want to become a DAO or more decentralized, how are you going to deal with all of these members actually being on, or users being on multiple chains? So in the last Educate series, there is a video on pretty much how you can do like on-chain, multi-chain governance. Another use case that I think is actually really cool, and it actually is being worked on. You can see this application called Oisy Wallet. It is completely open source, so you can see how it's actually being implemented. But I like to think ICP canister smart contracts as maybe they are these cross-chain abstraction wallets, you would say. And then I think how like I envision it is one of the use cases that we saw was that, for example, there was a team that actually was accepting crypto payments for a group of people that don't really have any experience with crypto. And how they handled that was they created an ICP canister smart contract, and they actually themselves created a ECDSA or Schnorr or Schnorr based address for every single person, and then they themselves would sign it for they would sign for these users. So that's one example of how you might enable a Web2 experience for folks that aren't as familiar with crypto. In this case with Oisy Wallet, how their user flow works is you actually sign in with internet identity, which again is an authentication service that allows you to authenticate using some sort of passkey on ICP, or a passkey such as a fingerprint or a Face ID, and then it will then authenticate, and it will then actually allow you to then it will actually then create you an ECDSA or I think a Schnorr address or a Taproot address now, and you will then be able to transact in this wallet, and your ICP Canister smart contract ultimately can be your wallet, which is super cool. And then, like I was saying earlier, maybe this like token swap layer for all chains. Like I was mentioning, like kind of having like converting BTC to ETH is maybe like is an expensive endeavor, or also like is an expensive endeavor, but maybe like swapping from ChainKey BTC to ChainKey ETH or to any other token, that would be definitely much cheaper. And like maybe ICP in the future could be this token swap layer for all of these chains. Like the expectation is people would have all these tokens, and then they can kind of swap all these like ChainKey tokens, and they can kind of swap between each other and ICP. And then again, like once they want whatever end token they actually really want, so for example, if they want ETH, then they can convert it they can have ChainKey ETH and then convert it to ETH. Another aspect is I think on-chain rewards. I also mentioned this already, where you can give people rewards based on one of the ChainKey tokens. And once they kind of meet a threshold, then they can convert it to like BTC, or you can just continue to keep or continue to give them BTC or ChainKey BTC, because actually in ICP there's actually no restriction on how little you can convert ChainKey BTC to BTC or like any of the other tokens. So what you can do is you can give them the rewards in ChainKey BTC, and then whenever they decide, they can actually then convert it to BTC. So I think this would be really great for gaming, for shopping, for any like rewards app that like does microtransactions, because I think microtransactions have been a really big pain point on other native chains because gas fees are so expensive. So why not use chain for example like ChainKey BTC or ChainKey ETH? And then the other use case that we've seen is maybe using ICP as a co-processor. So I've mentioned a couple of times now where one of the things about ICP is like you could like listen into different events on many different chains and do something after you like know of that event. For example, I don't know, like let's just say like whenever someone sends your wallet ETH or something like that, you do some sort of functionality. That can also be a great use case as well, in terms of like thinking about like what are some of the programmable things that you can do in order to like what are some on-chain events that you want to listen to, and what are some of the programmable things that you want to do as a result of those on-chain events. Well, we're trying to towards the end. Like I definitely can take any questions, but there are also some resources that I'd like to share about what I've talked today. So for Chain Fusion documentation, there's Chain Fusion documentation. There's also other Chain Fusion ecosystem products listed, and you can also take a look at the IC data dashboard in terms of like if you want to see any data on any of the ChainKey tokens as well. But with that, thank you so much, and I'll take any questions right now. Yes, I can hear you.
It looks like people are excited to catch on, and I'm encouraging that a lot. Everyone also get for the last session, which will be on Thursday, I believe. I don't think there's any questions to take from here. Do you have anything else to say about?
Awesome. Well, thank you so much, guys. And can't wait to hear you guys what you guys do at the hackathon. Especially, not only think about Bitcoin, but think about like the holistic holistic part of just like Bitcoin, and how can maybe you can connect it with other chains, and how Bitcoin can also be used to maybe help other chains fuel other chains. You can just do that so easily with ICP.
There's a question.
Sounds like you want to know more about Bionic and Ordinals. I know that Bionic, they did have a session kind of earlier, so you can dive in to the recording about that. But yeah, like I mentioned, so Bionic, Bionic is a decentralized Ordinals marketplace that is built completely on ICP. I actually don't know their full architecture, but at least for ordinals, like what you can do on ICP is you can, on ICP Canister smart contract, you can generate a taproot address, which is the address that you would need in order to hold an ordinal. So an ICP Canister smart contract can hold and trade ordinals, and yeah, and so I guess if there's anything else that you wanted to, I guess deep dive a little bit more, we can definitely talk about that, or can send over some resources.
There's also a question in the questions tab regarding the querying of Bitcoin blocks, and if you could speak more about that.
Okay, yeah. Let me see here. Yeah, so there is, I can send you the documentation around the management canister, but there is something called a management canister, or think of it almost like a kind of a protocol canister that anyone can kind of query to get information. So in this regard, we have a function called Bitcoin underscore get underscore headers, where you can actually reach, or in this case, you can actually retrieve the at least the headers. Let me see in terms of the blocks. Give me 1 second. There is a way to read Bitcoin state. Yeah, let me just include the documentation here. Yeah, you can learn more about reading Bitcoin state there. And yeah, let me know if you that have any other questions. I think that we have to maybe update it with Bitcoin underscore get headers. But yeah, that should be a function that you should be able to call. I'll also add the spec as well, because I think that's where you will see that function listed. Okay, so the function actually is Bitcoin. Let's see here. The function is Bitcoin underscore get underscore block headers. Yeah, so it is so there is a guide on how you would interact with the management canister within, and so you would create your own ICP canister smart contract, and then there's an example function in how you would call the management canister, and from that then you can call Bitcoin underscore get underscore block underscore headers, and with the arguments on what headers which blocks you want, and then it should return that data. Great, awesome. Glad to hear that was helpful.
Looks like we have no more questions. Thank you everyone in the chat for the activity, and see you on Thursday. All right. Thanks everyone.
Thanks everyone. Thank you so much.